Hello friends, welcome to Learner's Planet. Friends, this is our 7th session for polynomials and we are discussing applications of factor and remainder theorem. In previous sessions, we have done a good number of problems based on factor and remainder theorem. In this session, we'll be continuing with the same. Let's discuss the first problem of the session. Now, in this question, we have to use factor theorem to determine the value of k for which x plus 2 is a factor of x plus 1 raised to 7 plus 2x plus k whole cube. Now let's have a quick recap of factor theorem for this session. X minus a is a factor of px if PA is equal to 0. This is what the factor theorem is. Now, in this question, we are given that x plus 2 is a factor of this. So, if x plus 2 is a factor of this polynomial, then if we put x is equal to minus 2 in this expression, the value of this polynomial must be 0. So, let's go step by step. So, first of all, let's take this polynomial as fx. Now let this polynomial be gx. We have to find out the value of a according to this, or we can equate it to 0, or we can find out the roots of this polynomial. So x plus 2 is 0. That means x is equal to minus 2. Okay. Now we have to calculate the value of f of minus 2. Now put the value of x as minus 2 in this expression. So it's minus 2 plus 1, that is minus 1 raised to 7. Then 2 into minus 2, that is minus 4 plus k whole cube. Now, according to the question, x plus 2 is a factor of this expression. That means f of minus 2 must be 0. That means minus 4 plus k whole cube minus 1 should be 0. That means minus 4 plus k whole cube should be 1. That means minus 4 plus k should be 1, or we can say k is equal to minus 5. Okay, we took cube root of both the sides over here. 1 and 1 cube, both of them are same. So minus 4 plus k will be equal to 1. So k will be, it will be 1 plus 4, it will be positive 5. Okay, so I hope you are clear. Now let's see this interesting question. If this polynomial has x plus 2 as a factor and leaves a remainder 4 when divided by x minus 2, then we have to find out the values of a and b. Now let's begin to do. Let's assume this polynomial to be fx. So fx is equal to ax cube plus bx square plus x minus 6. Now x plus 2 is a factor. Let x plus 2 be gx. Let's find out the 0 of this. So x is equal to minus 2. Now if x plus 2 is a factor of fx, then f of minus 2 must be 0. So let's calculate f of minus 2. So it's a into minus 2 cube plus b into minus 2 square minus 2 minus 6. So it's minus 8a plus 4b minus 8. And according to the question, it should be 0, since x plus 2 is a factor of ax cube plus bx square plus x minus 6. That means f of minus 2 should be 0 according to the factor theorem. Now, the next step is this polynomial leaves a remainder 4 when divided by x minus 2. Now here we use the remainder theorem. So let it be hx is equal to x minus 2. So if this polynomial is divided by x minus 2, the remainder is 4. So first of all, by using remainder theorem, we calculate a remainder when this expression is divided by x minus 2. So first of all, find 0 of this, which is x is equal to 2. So let's calculate f of 2. So f of 2 is a into 2 cube, that is 8a, plus 2 square b, that is 4b, plus 2 minus 6. So it is 8a plus 4b minus 4. So we are getting the remainder as 8a plus 4b minus 4. And in the question, this remainder is actually 4. That means this expression is nothing but 4. So 8a plus 4b is equal to 8. Now we are having a set of simultaneous equation. That means we are having two equations and we have to get the values of a and b. Okay. Now we are having two relations which I have written over here, and now we have to calculate the value of a and b. Okay. So first of all, we can add both of them. So I write 8a plus 4b minus 8 is equal to 0. Let's add both of them. So this is negative and this is positive, so they will get cancelled. And 4b plus 4b is 8b. Then minus 8 and minus 8 is 16 is equal to 0. That means b is equal to 2. Now put the value of b in any of the equation and get the value of a. So I just write it over here. It's 8a plus 4b, that is 4 into 2, which is 8, is equal to 8. That means 8a is equal to 0. That means a is equal to 0. So we got the value of a as 0 and b as 2. And in this question, we have applied remainder theorem as well as factor theorem. I hope you are clear. Now in this question, we have to find out the values of alpha and beta if x plus 1 and x plus 2 are factors of this polynomial. So further, let's use factor theorem. Let it be fx. So fx is equal to x cube plus 3x square minus 2 alpha x plus beta. Now if x plus 1 is a factor of it, then first of all, find out 0 of this polynomial. It's x is equal to minus 1. So if x plus 1 is factor of this polynomial, then f of minus 1 must be 0. So let's calculate f of minus 1. So put the value of x as minus 1 in this expression. So it's minus 1 cube will be minus 1 plus 3 into minus 1 square, that is 3. Put x is equal to minus 1 over here. So minus 2 alpha into minus 1, it's 2 alpha and then plus beta. Okay, so it is 2 alpha plus beta plus 2, and it will be 0 since x plus 1 is a factor of x cube plus 3x square minus 2 alpha x plus beta. So f of minus 1 must be 0 according to factor theorem. Now similarly, x plus 2 is also a factor of it. So let's calculate the 0 of x plus 2. It's x is equal to minus 2. So if x plus 2 is a factor of it, then f of minus 2 should also be 0. So let's calculate f of minus 2. It's minus 2 cube, that is minus 8. Then minus 2 square, that is 4. 4 into 3, 12. Minus 2 alpha into minus 2 is 4 alpha. Then plus beta. That is 4 alpha plus beta plus 4. Even it should be 0 since x plus 2 also is also a factor of fx. Okay. So f of minus 2 should be 0 and f of minus 1 should be 0. Now we are having a set of simultaneous equation. So we can calculate the value of alpha and beta. Let's see how. So we just write the equations like this. Then I subtract this expression or this equation from this equation. So if I subtract, the signs will be changed. Okay, if it is positive, it will be negative. If it is positive, it will be negative. That you might be knowing. If one expression is subtracted from the other expression, the signs of the latter expressions are changed. So 2 alpha minus 4 alpha is minus 2 alpha. Then beta minus beta will get cancelled. And 2 minus 4 is minus 2. And it should be 0. That means 2 alpha plus 2 is 0. That means alpha is equal to minus 1. Okay. Now put the value of alpha in any of the equation and get the value of beta. So it's 2 into minus 1 is minus 2 plus beta plus 2 is equal to 0. That means beta is equal to 0. So we calculated the value of alpha is minus 1 and beta is 0. I hope you are clear. Now let's see this interesting question. Using factor theorem, show that x minus y, y minus z and z minus x are factors of this expression. So let's begin. Let this expression be fx. So fx is equal to x, y square minus z square plus y, z square minus x square plus z, x square minus y square. If x minus y is a factor of this polynomial, then x minus y must be 0. So x is equal to y. That means if x minus y is factor of this polynomial, by putting x is equal to y, the value of this polynomial must be 0. So let's calculate f of y. So what we will do, we'll put the value of x as y. Okay, so it's y into y square minus z square plus y into z square minus y square plus z into y square minus y square. So let's solve it. It's y cube minus z square y plus yz square minus y cube plus it's 0. Okay, so it's y cube minus y cube is cancelled and it is z square y positive and z square y negative. So we are getting 0. Okay, so by putting x is equal to y, we are getting the value of this expression as 0. That means x minus y is definitely a factor of fx. Okay, now let's do the same working for y minus z. Now if y minus z is factor of this expression, then let's see, y minus z is 0. That means y is equal to z. 0 or root of this equation is y is equal to z. Okay, so if I put y is equal to z in this expression, the value of this expression must be 0 if y minus z is factor of it. Okay, so let's calculate f of y. And I'll be putting the value of z as y. So it's x y square minus, instead of z I'll be putting y. So it's y square plus y square minus x square plus z, I'm sorry, it will be y, x square minus y square. So let's solve it now. It will be 0. Then it is y cube minus yx square plus yx square minus y cube. So we got 0. So f of y is 0, and that means y minus z is definitely a factor of this polynomial. Okay, and let's do the same working for even z minus x now. Now z minus x is 0, that means z is equal to x. So we can put z as x in this expression. So let's calculate f of x and put the value of z as x. Okay, friends, you can do you can go either way. You can put the value of z as x, or you can put the value of x as z, doesn't matter. Okay, so f of x is x y square minus, instead of z I am putting x, so it's x square plus y, x square minus x square plus x square minus y square. So it's x y square minus x cube plus y x square minus y x square. I'm sorry, it will be 0. And then it's x cube minus x y square. So it's cancelled and it's cancelled. So further we are getting 0. That means even z minus x is a factor of fx. So we can say x minus y, y minus z, z minus x, all of them are factors of this fx. Okay, I hope you are clear. Now let's see this question, which is quite similar to the previous one. In this question, using factor theorem, we have to prove that a plus b, b plus c, c plus a are factors of this particular expression. So let's assume this expression to be, say, y. Now what y is? A plus b plus c whole cube minus a cube plus b cube plus c cube. Now if a plus b is a factor of it or not, we have to see. So let's put a plus b as 0. That means a is equal to minus b. Now if we put a is equal to minus b in this expression, and if we get 0, then a plus b will be a factor of it. So let's put the value of a as minus b in this expression. So y will be, it's minus b plus c whole cube minus b cube, that is minus b whole cube, that is minus b cube plus b cube plus c cube. So it is c cube minus c cube, that is 0. That means if we put a is equal to minus b in this expression, its value becomes 0. That means a plus b is a factor of this polynomial, or we can say expression. Let's do the same working for even b plus c and c plus a. Now b plus c is 0. That means b is equal to minus c. So let's put the value of b as minus c in this expression. So a minus c plus c whole cube, then minus a cube, it's minus c whole cube, that will be minus c cube, and then plus c cube. So it's a cube minus a cube. Further we are getting 0. That means even b plus c is a factor of this expression. So now proceed the same for working for c plus a. Now c plus a is equal to 0. That means c is equal to minus a. So if we put c is equal to minus a in this expression, let's see what we get. It's a plus b minus a cube minus a cube plus b cube, and instead of c I am putting minus a, so minus a whole cube will be minus a cube. So it's b cube minus b cube. Still we are getting 0. That means a plus b, b plus c, c plus a, all of them are factors of this expression. Okay, the very simple application of factor theorem. I hope you are clear. Friends, I hope you might be clear about factor theorem and remainder theorem. In our next session, we'll be learning factorization. Till then, you do revise this session and the previous sessions of remainder theorem and factor theorem. So in our next session, we'll be using factor theorems for factorization. Bye-bye.